Welcome students to Six Sigma Green Belt lesson number 21. If you look at the table of contents, we have covered the organizational drivers, and today we'll be talking about goals and projects. Under goals and projects, we'll be talking about project selection methodology, PDCA cycle, PDSA cycle, which was invented by Dr. Deming, and PDCA was invented by Japanese. And then we will be talking about classic problem solving methodology, and then we'll be talking about briefly about the DMAIC process methodology. All the reference material is attached with this video. So what we'll do is we'll discuss all these topics in detail in this lecture, but please do refer to the attached reference material, which is going to be a PDF file for each of these topics to get a better understanding. So we start with selection of project, and then we'll discuss the methodology, and then we'll talk about PDCA, PDSA, and then classic approach to problem solving. Moving forward, the three methodologies that you saw on the previous slides, what they do is they use those three steps discussed in the slide 2, use the following seven original quality tools. Number 1 is check sheets for any counting or any rejects that you have that you need to do. Number 2 is you can Pareto the issues. Number 3 is draw a process flow diagram. Number 5 is the next one is the scatter diagram, which you may want to do just to see how strong the relationship is between the two variables and if it's worth working on that project. You can also do control charts, and with control you can do run charts also. Then you can do histograms, and then in the end is the fishbone diagram, which was really invented by Dr. Ishikawa, and he gets the credit for this. So these are the 7 original quality tools that are used when we do the PDCA, PDSA, and the classic problem solving methodology. Whenever we use that, we use all these 7 quality tools. In addition, to the above 7 tools, at times brainstorming sessions do occur, and then you come to consensus to reach a decision or to make a decision, or you can do multi-voting if it's a team-based approach. So in addition to the 7 quality tools that we discussed, we also do brainstorming, consensus, and multi-voting just to make sure that we make the right decision. Many problems or projects they can be solved using above mentioned tools. At times, depending on the problem or the nature of the problem, more powerful tools are used. And a good example is the DMAIC problem solving methodology. So at times we may end up using this technique if the above tools cannot get the job done. So under DMAIC, what comes is the person or the team who's solving the problem, they use statistical software for data analysis. They also talk about QFD, which you don't need to know right now. These are just the tools that the DMAIC process covers. Next, under that you can do FMEAs, you can do process capability, you can do multi-variation analysis, you can also do ANOVA if you have different suppliers you want to combine or check who's better You can do regression, correlation. You can also do design of experiments. We normally call that DOE. You can do hypothesis, testing, where you define the null and alternative hypothesis. In addition to these, you can do control plans for your processes and then add mistake proofing system in place, and then there is the confidence interval. And these come in the software can do everything. For example, Minitab or JMP, whatever you guys are using, all these items that we discussed, they can all be done in the software. So let's move forward, talk about PDCA. This was invented by Japanese and it's graphical and logical representative of how many organizations solve issues. So this cycle goes by, there are 4 things in this PDCA, and it looks like over here is plan, 2 is do, 3 is check, and number 4 is act. And we'll talk about plan, do, check, act in detail. What does that mean? So basically the plan phases, you establish a plan for achieving your goals, and that's done under the planning stage. Number 2 is do, and you basically in this stage what you're doing is you're implementing the plan. Number 3 is check. At this stage, what you do is you measure and analyze your results. And the last one is act. And what we do here is implement required changes based on the results. It may be that you don't need to implement changes, or it could be that you do need to implement changes, and then this is where you do that. And it's a process, and then you repeat the issue again. Basically, it's a closed loop, and then you go plan, do, study, act, and you keep on repeating it until you get to the bottom of what you need. Also, flow diagrams. Process maps. They are good graphical representation of the above stages. What I mean by the above stages is, I'll discuss that in next slide. What happens is, when you do a process flow diagram, you divide your work into stages, and these stages all together form a process. Each stage has a customer. It could be milling department, let's say for example as one stage, and the next department could be a lapping department where you lap the machined parts, and in this case the lapping department is the customer of the machining department. So each stage has a customer. The PDCA cycle when you implement the PDCA cycle, what that does is you end up sending superior products to the next stage. So if you follow the way the PDCA cycle is supposed to work, then you'll get a good product from the process, and then you can deliver it to the next stage. Now we'll talk about PDSA, and this was invented and proposed by Dr. Deming. Dr. Deming, he did not like the PDCA cycle too much. And this PDSA cycle, it's a continuous improvement loop, and which is actually its spiral. Dr. Deming's main focus, so his main focus was to resolve an issue using this technique, but should be a team-based approach. So the objective of the team is to improve the input and the output of any stage. And again, the stage comes from the process flow diagram that you generate. The other part is team selection. What Dr. Deming recommends is he suggests that members from different areas of plant, you can bring those members from different areas of the plant, but ideally he suggests that the members should be from one area or a stage, whatever you want to call it, in the plant operation. So to summarize the team selection, he said you can Dr. Deming suggested that you can pull members from different areas of the plant, but ideally what he likes is they should be from one area or a stage in the from the plant operation. Dr. Deming's PDSA cycle, it includes the following. P is plan again, but what you do here is you look at what changes are desired, next thing is you need to know what data is needed, and then is there a need to plan and implement a test. And the last one under plan is you look at what is the most important accomplishment of the team. So to summarize the planning stage, you look at what changes are desired, what data you need to collect, and is there a need or do you guys need to implement a test of any kind to basically support the problem. And the last one is you want to look at what is the most important accomplishment of the team. And also, I missed one. The last one is you decide how to use observations. So all these come under plan. The do, which is D. Over here you carry out the plan. It's similar to the PDCA cycle, but here Dr. Deming prefers you do that on a small scale. Under study, which is the S part, you'll observe the effects of change of the test. So you're basically observing the effects of the change if you're implementing a test. The last one is the act. So under act, what we do here is you study the results, also you look at what was learned, so basically lessons learned, what can be predicted, the other one is will the result of the change lead to number A, improvement of all stages or for all stages. B is there going to be some activity to basically satisfy and delight the customer, and it's all about the customer when you are in the business. So what happens next is you repeat the plan stage, which is B, with information that you gathered from this experiment. And then you repeat the second stage, which is do, and you continue. Both the PDCA and PDSA, they both are powerful tools if you use them correctly for improvement projects. The key is to follow each step and what the definition of each step is. You should follow that, and then it becomes a very powerful tool for your project improvements. Another thing Dr. Deming, he recommends is every member on the team should participate equally generate ideas for improvement, etc. And then you look at lessons, whatever lessons learned should be corrected. Should be corrected. And once you do that, what happens is you make a fresh start for whatever the project that you are going to be working on. And you make a fresh start with clear ideas and when we do everything that was mentioned above, when we do this, it's a sign of advancement for the company. So if you really follow the process, these two processes, the way they're supposed to work, you'll see a significant benefit from those. So we'll end this lesson here, but we'll talk about the classic team problem solving steps and the DMAIC process, and also the flow chart of the problem solving steps. We'll discuss that in the next lesson because we're getting close to the time limit here. I don't want to go over. But please do check the attached material with the slides, and if you have any questions, just contact us through the website. Thank you for participation. Have a wonderful day.